All right, this is a brief introduction to the Universal Translator. I'm Austin Blanco, the owner of ARC, and I wanted to show a little bit about why I made this thing and how it works, the general idea behind it. Hopefully, I'll be able to keep people's interest. Um, the Universal Translator was basically built because of a common frustration that I've had as well as other people in the industry have had. I know that several different people that work in the similar field that I do, where we're trying to build microscopes, integrate them, and generally get things working that are oftentimes not designed to work together. We all have this frustration. That is, what do I do if I have a commercial piece of software that there's not really a good interest to support a device, but I also have a customer that really needs that device to do their research or to expand on their work. And so, the answer is not just, we're not going to do it. It's a question of how difficult is it to do it. No one's really at fault per se. It's not an issue of somebody, like the large commercial software providers. Oftentimes, there's not a financial case to write a driver. So, if there's only one or two sales that they're going to get, it just doesn't make sense to do it. But then the customer needs a driver. And meanwhile, the hardware device company oftentimes doesn't have access to write those drivers. So it's this somewhat unanswerable question. Over the years, the thing that I kept stumbling across is there's got to be a way to emulate these devices. Meaning, I'll just tell the software I'm a device that is supported and then do whatever I need to do on the back end. The reason I named this product the Universal Translator is after the Star Trek Universal Translator, because that's effectively what it's doing. It's talking in one language, and then it can talk in another language to another device on the other end. This is the general structure of the device. So I've got a camera here set up to show it. It's just a little box. So inside the box is a microcontroller as well as a miniature PC or UMPC. The microcontroller is set up to emulate anywhere from 1 to 3 serial ports. So you can actually have this thing set up to be, COM 4, 5, and 6, which could be 3 different devices. I actually recently did that for somebody. And in doing so, you can have your software talking to supposedly 3 different devices, when in reality, it's just talking to this box. Now, on the other side, you could connect numerous devices here to these USB hosts, and these are standard USB 2 compliant hosts. In addition to that, you can run analog devices in or out. These are 0 to 3.3 volt analog IOs. And then you've got a 0 to 5 volt 200 milliamp buffered TTL IO on the backside. Now, I have one of the TTL pins connected up to an oscilloscope to show the pin status. There's also an internal status LED, which is a 3-color LED and can be used for just indication. Now, I've programmed a couple of examples here that rely on that LED. So what I'm going to do is pull up an old copy of commercial software. This happens to be Elements. So I'll grab that, put it on the screen here. And I've got this set up right now. Double check my software is actually running. All right, I'm going to talk to the Universal Translator right now, and I'm going to tell it to run emulation for a common product that's kind of supported all over the place, and that is a Uniblitz VMM series shutter controller. So if I go to the Devices menu in Elements, and I connect up this shutter, this is a great device because it's actually like universal or unidimensional directional communication, meaning for the most part, the host computer just talks and sends commands, and you don't have to have anything back. We can, of course, support bidirectional communication, but for this example, it's nice because you don't even have to. And now if I open and close this shutter, what I should see is that the LED status should change from green is off in this case, and then off is on. And then over here on my oscilloscope, I should see that my 5 volts is going high and low. So if I snap an image with this shutter set up as active, it should go high and low pretty quick. And if I, I guess that's not the active shutter in Elements. Let's go fix that real quick. There we go. There we are. So now I get an active shutter when I take a picture. So that's an example running just a VMMD1. That's a relatively simple device because there's only 2 commands. It's on or off. More complicated device would be something like a Spectra X. So that device is a well-distributed, popular LED engine with published protocol. And on that one, there's an older protocol most people support. So I'll just give an example of that. So what I'm going to do is disable the driver emulation on the Universal Translator right now. So just turn that off. And then I'll go to my other driver, activate that. And now, if we disconnect this device and then connect up, let's see here. Do we have this device added? Guess we don't. So we'll go ahead and turn it on. That's going to be the Spectra Aura. So once this turns on, we'll put it on our COM port. All right. And away we go. Now, I might be able to configure things like how many lines are on this thing. I think I've turned some of them off just to make things easier. I've only got 4 different states activated here. So now that I have this set up, what I'm able to do, if you watch the LED status down here, and I turn on, say, the green channel, I get the green LED. On the other hand, if I turn on, say, the 470 channel, I'll get a blue LED. So this enables us to kind of emulate different devices. So there's a blue LED. So what I'm going to do right now is I'm going to go through and set these different presets up here. I believe these presets should be set up to work. Let's see. Yeah. There we go. Set that guy up. Yep, on, off. Yep, on and off. So now that I have 3 of these set up and configured for switching, what I can demonstrate is a time lapse. So we'll do a multi-channel time lapse, and we'll hit run now, and we can see that the LED channel is switching. Now there is a delay in doing this because you do have to talk between, here's just the different colors. It's kind of hard to see. The camera doesn't do it justice. There is a delay between communication. That delay tends to be between 5 and 15 milliseconds. So for most people, that won't be enough to matter, especially when you're considering that you either aren't able to control the device or it's very difficult to control the device versus being able to with a slight delay. In certain cases, we can speed that up, especially if we can exploit the microcontroller on the front end for higher speed responses. And a lot of that delay is simply because USB to serial emulation takes some time, and so we're doubling that time up in both directions. But again, the big picture is, you know, if you've got a stage and that stage is not supported, but there is supported communication on an open protocol, published protocol from a stage company, we can emulate that stage. So in many cases, this will enable you to do things like positional control in software that was not previously possible to achieve, as well as to emulate devices in commercial software that can then support even homebrew devices. So if there's things that you want to create that run off of TTL, you can use a commercial driver or a commercial compliant driver to talk to your software and then do whatever you want on the back end with TTL. Now, another thing to kind of point out about this is that there's really nothing stopping anybody, or including us, like which we'll do this for, depending on the situation, we can work with customers to do this. We could connect up multiple devices to this unit. So for instance, if you had a filter wheel and you had a laser and you had a laser controller that required power modulation, you could have all 3 of those devices connected to the Universal Translator, and all 3 of those devices could be driven by a single serial input command or a single switch state. So for deploying a more complex system and maybe a simpler software package, that could be really beneficial. In essence, this thing could control all of the illumination components or even some stage components natively, and then you don't have to have a super complicated control scheme on your backend software or your host PC software. So I think it's got a lot of possibility, and really the limit, I think, is going to be the diversity of challenges that people bring up to see whether we can use this thing to solve those challenges. But Yeah, I'm hoping that this is a sufficient introduction. If you have questions, feel free to reach out either by posting on this video, contact me on the blog, or you can get a hold of our company at advancedresearch-consulting.com. We're also on Twitter and Instagram and all the usual social media sites. I can be reached, of course, at my website, austinblanco.com, or at my blog, which is /blog. And thanks for watching this video.